Welcome to the review of Math 136 Practice Final for 2020. We're going to work through each of the points on the review. There are 25 questions and we're going to work through them all. So starting with question number 1, we have a rational equation. Remember, when you have a rational equation, you want to figure out what the least common denominator is. To find the least common denominator, you're going to have to factor this quadratic right here. We would factor that using our asterisks. So we're looking for two numbers that multiply to give us -6 and add to give us 5. We would use the two numbers, +6 and -1. So this right here factors into m plus 6 and m minus 1. With that being said, I now look for my least common denominator. Comparing all my denominators, I have to include anything that's in at least one denominator. So I have to have m plus 6 and m minus 1. So now we're going to go through and we're going to multiply every single term by m plus 6 times m minus 1. If we've done this correctly, we should be able to cancel out the denominators of all the fractions. So this first one, the m plus 6's, will cancel. That leaves us with 4 times m minus 1 plus the second fraction, we can cancel out the m minus 1's. That leaves us with 1 times m plus 6 equals, and then for that last fraction, both denominators will cancel with what we were multiplying by, in this case, our least common denominator. That leaves us with 3m plus 6 in the numerator. Now we're just going to take this linear equation and we're going to solve for m. First thing we wanted to do is distribute to get rid of our parentheses. And as always, if I get to going too fast, feel free to pause the video to get caught up and then resume when you are ready. So now that I've distributed, I want to go back through and combine like terms. So 5m plus 2 on the left side now. Subtract 3m from both sides and subtract 2 from both sides. That'll give me 2m equals 4. Divide both sides by 2 to get an answer of m equals 2. Moving down to question number 2, we're being asked to determine whether or not the function f of x equals x squared minus 4x is 1-to-1. Remember, the parent function of a quadratic looks like this, a parabola. Again, could be anywhere. We have to decide if this graph would pass the horizontal and the vertical line test. This would not pass the horizontal line test, so my answer would be no. It does not pass the horizontal line test. So it would pass the vertical line test, but if I drew in this horizontal line here, we would be crossing that parabola 2 times, so it's not 1-to-1. For question number 3, we're going to solve the compound inequality. We're going to write our solution set in interval notation and graph it. So to solve this, we want to take this compound inequality and solve for x. Keep in mind, with a compound inequality, you could either break it apart into 2 pieces. You could solve this piece, and then you could solve this piece into separate problems, or you could do it all together, like I'm getting ready to. So we would have to do the same operation on both sides, left and right, as well as the middle here. So if I subtract 5 to cancel this 5 out here, I would have to subtract 5 on the left and the right sides. So that gives me -12 is less than -3x less than or equal to 0 now. And then to get rid of the -3, I would divide every single term by -3. Keep in mind, when you divide by a negative, you have to flip your signs. So this sign actually flips this direction. And this sign flips this direction. And it's always customary to rewrite the reverse. So 0 is less than or equal to x is less than 4 would be what I want to graph. So in interval notation, we would write our bracket 0, 4, and then a parenthesis. So remember, anytime you have an equal to, you use a bracket. Anytime it's just less than or greater than, you just use a parenthesis. So then when I graph that, again, I'm going to use those same symbols. I'm going to use a bracket at 0, a parenthesis at 4, and then I'm just connecting them in the middle. Moving on to question number 4, a ball is thrown downward from a window in a tall building. Its position at time t in seconds is represented by s equals 16t squared plus 32t, where s is in feet. How long to the nearest tenth will it take the ball to fall 92 feet? So if s is the height in feet, we want to replace s with 92. And leave the rest of the equation alone. And then we're going to have to solve for t. So this is a quadratic. The first thing I notice about this is that there is a greatest common factor. So I'm going to write this in standard form first, and then I'm going to divide everything by that common factor. So the greatest common factor in this case happens to be 4. So we're going to divide every single term by 4. And then we're going to go ahead and see if we can factor this. If we can't factor it, we know we can always use the quadratic formula. So when I look at the factors of 4 times -23, that gives me -92. So when I look at my factors in 92, I have 1 and 92, 2 and 46, or 4 and 23. I cannot take any of those numbers and put them together to get +8, so I'm going to have to use the quadratic formula. So in the quadratic formula, I'm going to use an a value of 4, a b value of 8, and a c value of -23. So here we have x equals -b, so I'm going to have -8 plus or minus, and then the square root. Underneath that square root, I need b squared minus 4 times a, which is 4, times c, which is -23. all divided by 2 times a. And then I'm going to work to simplify. I'm going to type this highlighted portion into my calculator, making sure to use my parentheses. And then there's a few different ways you could go about answering the rest of this question. Since this is a word problem and we're talking about time, our instructions tell us to round to the nearest tenth. So I want to, at this point, just break apart into -8 plus the square root of 432 divided by 8 and -8, pardon me, minus the square root of 432 divided by 8. When you type these in your calculators, if you want to do it all at once, you must use parentheses around the top. So if I take -8 plus the square root of 432, that gives you 12.7846. And then you would divide that answer by 8 to get t equals 1.59. Remember, we were asked to round to the nearest tenths place, so 1.6 seconds would be our first answer. For our second answer, we're going to take -8 minus the square root of 432. That gives me -28.78. I'm going to divide that again by 8, and that gives me a time of -3.6 seconds. And then remember, time is not negative. We don't talk about negative time, so that answer is actually extraneous. Question number 5, we're going to graph this piecewise function. Keep in mind these things over here on the right side are our constraints. So for the first one, we can only use x values that are less than -1. So that's going to be the left side of our graph. I'm going to go ahead and make an XY table for it. And I'm going to plug in any number that's less than -1. I'm actually going to start at -1, and then remember that's going to be an open circle because it's not equal to. So I'm going to use -1, -5, and -10 just so I can get some numbers throughout my graph. And again, we are plugging all 3 of those numbers into the top part of the function, the x plus 4. So I'm going to take each part or each number and plug it into x plus 4. So if I plug -1 into x plus 4, I get 3. If I plug -5 in, I get -1 and -6 for that -10. So I'm going to go ahead and graph these on my coordinate plane. So -1, 3, make sure you have your open circle there. 5, -1. And then 10, -6. And we're going to connect those. Keep in mind that this part of the graph continues on into the negative direction, so it heads over to the left forever and ever. Then I'm going to repeat the process with the bottom equation. So -x I'm going to use for x values that are greater than or equal to -1. So -1, again, I like to spread my points out when I graph them. So I would use +5 and +10. Again, you can use whatever number best suits you. So when I plug in -1, keep in mind here, I just want the opposite of whatever the number I was given. So -1, opposite is +1, opposite of 5 is -5, and opposite of 10 is -10. Then I'm just going to graph those. And then remember for that first ordered pair, -1, 1, since the bottom constraint can equal -1, I better put a solid circle for that value right there. Then this graph continues on forever in the right direction. So my graph would look like this. Question number 6. An initial investment of $480 is appreciated for 2 years in an account that earns 17% interest compounded quarterly. Find the amount of money in the account at the end of the period. So if we look at our formula sheet, we're going to that compound interest formula that's on the back side on the top right-hand corner. It is A equals P 1 plus R divided by N to the NT power. So then we just have to decide what all of these numbers are or where they're going. So first thing, let's discuss A equals the amount in the account at the end of the period. That's actually what we're trying to find. So we're going to leave that the same. P represents the principal. That's your initial investment. In this case, it's $480. And then inside your parentheses, 1 plus. For R represents the interest rate. Always convert that interest rate to a decimal, so 0.17. And then N is the number of times your interest is compounded in 1 year. So if it's quarterly, we're going to use the 4 because there are 4 quarters in a year. And then our exponent is going to be N times T. N is again the 4 for the quarterly. And T represents the number of years, in this case, 2. So if I'm good at using my calculator, I can go ahead and type this all in my calculator all at once. If not, you can do it in pieces. I would do this piece, raise it to the 8th power, and then multiply it by 480. You should get a final answer of $669.65. Keep in mind, we're referring to money, so we always want to round that to the nearest cent. Question number 7, we're going to graph the pair of functions f of x equals the absolute value of x and g of x equals -0.5 times the absolute value of x minus 2. If you take a moment and look at your reference sheet, the parent function for the absolute value of x is actually given to you. So we're going to go ahead and graph that. Remember, absolute value just makes a V shape. Like this. So there's my parent function. Again, that graph is given to you on your reference sheet. And then remember back from parent functions that this number right here, since it's in with the x value, is going to shift the parent function right to. The numbers out at front do some shrinking, compressing, and since it's negative, it's actually going to flip it over. I wanted to point out that it's going to move it right too, so that when I make my XY table, I'm going to start with 2. And then I'm just going to plug in a couple different other numbers. Let's do -2 and +6. Then I'm just going to go to the original equation. Take x out, replace it with these values. So when I plug in 2, I get 0. When I plug in -2, I get -8. And when I plug in +6, I actually also get -8. So your numbers might not come out as perfect, but keep in mind it doesn't matter what order or what numbers you plug in, as long as you plug some of them in on the left, some of them in on the right, so that you can get a decent graph. So when I graph the second one, I'm going to graph the ordered pair to 0 right here, to -8, pardon me, -2, -8, and then +6, -8. And then I'm going to, again, connect them to get this graph right here. So that blue graph is g of x, the one that has had the transformations upon it. Question number 9, we're going to rewrite, oops, we skipped number 8. Question number 8, we're going to find the domain and range of this log function. We want to write our answer in interval notation. So for domain and range, remember your domain tells us that whatever number goes right in here must be greater than 0. So we're going to take 3 minus x and say it must be greater than 0. There's a couple different ways you could do this. I personally would probably just add x to both sides. So 3 is greater than x. We never leave these like this. We want to flip it so that x is on the left. So x is less than 3. So my domain is anything that is less than 3. So I'm going to go write my domain. Any number less than 3 would be -infinity all the way up until 3. 3 is not included, so I'm just using parentheses. And then remember, we can't reach -infinity, so we have to always use a parenthesis there. And then our range is going to be all real numbers. So we're going to write that as -infinity, comma, +infinity. And again, we can never reach positive or negative infinity, so we're using parentheses and not brackets. Moving on to question number 9, we're asked to rewrite the expression using sums and or differences of multiple logs. So the first thing I'm going to do is break this apart using our quotient property. So remember, log of the numerator minus log of the denominator. And then I can use the product property to separate this first logarithm even further. So that would give me log base 3 of x squared plus log base 3 of the 4th root of y. And then bring down the minus log base 3 of 9. A couple different things we need to do here. So we're going to bring this exponent down out front for the first log. So 2 log base 3 of x, that first one is completely simplified now. The second one, we are going to have to do a little bit of work. So we're going to take this part right here and I'm going to go over to the side and we're going to rewrite it. So currently we have the 4th root of y. We want to write that as a rational exponent. So that's going to be y to the 1/4 power. And if I would have log base 3 of y to the 1/4 power, that 1/4 must be moved down out front. So for the second log, we're going to have 1/4 log base 3 of y. Minus the third log. The third log, again, is another tricky one that you've got to simplify further. So log base 3 of 9 actually equals a whole number. So in this case, I'm just going to say x. So log base 3 of 9 equals x. If I write that in exponential form, it would be 3 to the x power equals 9. Well, 3 to the x power, we would use 3 squared equals 9. So x has to equal 2. So that tells us that log base 3 of 9 is just plain old 2. So log base 3 of 9 simplifies all the way down to just 2. And this right here would be my final answer. Question number 10, a company's weekly cost in dollars is given by this equation where X is the number of items produced during the week. For what number of items is cost minimized? So we're being really asked to find the X value of the vertex. So if I would graph this, it would be a parabola because it's X squared. And we want to find this point down here for the lowest cost. So we're going to take our formula to find your vertex. Remember, to find the x coordinate of vertex, you use the axis of symmetry formula. So x equals negative b divided by 2a. So negative b means take the opposite of the linear term of your equation. So opposite of negative 200 is 200 divided by 2 times a. And again, in this case, a is the number in front of the quadratic term, so 5. And then I'm just going to simplify this. So 200 divided by 2 times 5, well, 2 times 5 is 10. 200 divided by 10 would tell us that 20 items. So whenever I make 20 items, my cost would be the lowest. For question number 11, we're going to sketch the graph of f of x equals 3 to the x power plus 2. So this is an exponential equation. When we solve exponential equations, we always tend to use those same 5 values in our t-chart. So in my t-chart, I'm going to use -2, -1, 0, 1, and +2. Just going to take all of these numbers and plug them into the original right here for x. So for the first one, I would take 3 to the -2nd power plus 2, just calculator work, and that is approximately 2.1. So if I go ahead and plug all 5 of those numbers in, I end up with these 5 values that I'm going to need to graph. So if I graph -2, 2.1, it's going to be right there, approximately. It doesn't have to be exact. If I graph -1, 2.6, it's just going to be a little bit taller, a little bit higher. 0, 3 should be exact. 1, 5 again should be exact. And 2, 11 doesn't really fit on my graph, but I know it's going to be right up there. So then when I go ahead and draw my graph, it's going to look like this. Make sure that on the right side here that your graph flattens out, because there's an imaginary line right here that your graph will never cross. Question number 12, in January 1983, Anna starts a new job making a salary of $38,000. By January of 1986, her salary has increased to $46,300. What is the average rate of change in her salary between January of 1983 and January of 1986? So this is just a rate of change problem, y2 minus y1 divided by x2 minus x1. So we're just going to pick 2 points that we were given. I'm going to start with Anna's salary in 1986, her current salary. So $46,300 300. And then the 86 goes on the bottom. And then we're just going to subtract the other two values. So on the top, her original salary was 38,000 and the original year was 1983. So then we just want to simplify the top, simplify the bottom. So 8,300 divided by 3 is going to give you approximately $2,766.67. Want to label that money. That is her increase in salary every year between 1983 and 1986. Again, that is the average increase in her salary. I know it's an increase because it tells us it increased, and then as well, we have a positive number for this. Question 13, we are given f of x and g of x, and then we're asked to find f minus g of 2. The first thing I'm going to do is find f minus g of x. So I'm going to take f of x minus g of x. So that would be 3 minus 2x for f of x. And then be careful when you subtract g of x, you're going to subtract both terms. That's why I put it in parentheses. And then to get rid of those parentheses, we're going to distribute the negative by changing the signs in that second set of parentheses. So now we have 3 minus 2x plus 9x squared minus 4. I'm going to combine like terms to get 9x squared minus 2x minus 1. So that right there is the simplified version of f minus g of x. But keep in mind, we've never done anything with this 2 that we were given. So we're going back to the original, or the answer that we just got. And we're going to plug in 2 for both of these x's. So we're going to take 9 times 2 squared minus 2. And then again, we're plugging in the 2 again, minus 1. So we've just substituted that 2 in there for x. And then we're just going to type this in our calculator to get our final answer of 31. Question 14, we're asked to find the remainder when this polynomial is divided by x minus 2. There's 2 different ways you can do it. My suggestion would be that you use synthetic division. So I'm setting up synthetic division here. Remember, synthetic division is always 3 rows. And then the number of columns depends on the number of terms that you have. If you have a problem like this one with x to the 4th, you should have 5 rows. Keep in mind, you have to account for any missing exponent. So if I start with x to the 4th, I should go down to x to the 3rd for my next term. But in this case, I do not have any missing terms. Then to find our magic number out to the side, remember we have to set what we're dividing by equal to 0 to get the x value, in this case, positive 2. Don't forget this first term always comes straight down, so the 2 is just coming straight down. Then we're going to multiply to get the middle, so 2 times 2 gives us 4. Then we're going to add to get the bottom, so now we have a 3 at the bottom. Now I'm going to take that 3 and multiply it by the number out front to get the new middle term. Add straight down. So now I have negative 1. I'm going to multiply again. Negative 1 times 2 is negative 2. Add straight down to get negative 5. And multiply to get the middle. Negative 5 times 2 is negative 10. Add these together, and I get 0. So my new equation could be written using these 4 coefficients, But since the question is just asking me to find the remainder, all I have to say is the remainder is 0. And I know the remainder is 0 because that's the number I got in this final box. So whatever number is in that last bottom box with synthetic division is always your remainder. Question 15, the graph of a polynomial function is shown below. We're trying to determine whether the leading coefficient is positive or negative, if the degree is even or odd, and then we have to talk about the end behavior as we take our x values to approach negative infinity and we take our x values to approach positive infinity. So looking at this, I always start off with leading coefficient. Remember, if your leading coefficient is positive, your graph will do something in the middle and then continue up. So it'll start down here, do something in the middle, and continue going up. If it's negative, it's going to start by going down. Again, it could have as many humps in the middle as it wants, but it's heading down on the right side. So in this case, our graph is starting at the bottom and heading up at the end. So our leading coefficient must be positive. To determine whether the degree is even or odd, if the degree is even, the end behavior will be the same for both sides of your graph. So we're talking about where the arrows are heading. So in this case, one arrow is heading down, one arrow is heading up. That indicates that this function must be odd. And then for part C, we're determining end behavior. So for the first one, we want to know as x approaches negative infinity, where is y going? So y is approaching something. It's either going to be positive infinity or negative infinity. In this case, we're talking about this arrow right here. So it's heading to the left, so y is approaching negative infinity. And that arrow is going down, so the y values would be approaching negative infinity as well. When we talk about the other arrow or the other end, talking about the one over here on the right. So when I look at this one, my end behavior is going up, so my y values are increasing or approaching positive infinity. And that is all for question 15. Question 16, we're going to find the inverse of the function f of x equals, in parentheses, x minus 3 squared plus 2. First step to find the inverse, you're going to take f of x out and replace it with y. Second step, we're going to invert or flip x and y, so we're going to have x equals y minus 3 squared plus 2. And then once we do that, our objective is to go ahead and solve for y. So this is going to take us a few steps to get y by itself. First thing we're going to do is get rid of this 2 by subtracting 2 from both sides. So x minus 2 equals y minus 3 in parentheses squared. To eliminate that square here, we're going to have to square root both sides. So on the right side, the squared and the square root canceled, leaving us with y minus 3. And then on the left side, we don't know what the square root of x minus 2 is, so we're going to leave it as the square root of x minus 2. Then to get y by itself, we're going to add 3 to both sides. Oops. Keep in mind that 3 cannot be combined with the minus 2 because the minus 2 is underneath the square root and the 3 is not. And then for our last step, since we've got y by itself, we want to write this in inverse notation. So f inverse of x, and then we're just going to copy this portion down right here. So the square root of x minus 2 plus 3 hangs out at the end, and that is our final answer. Question 17, we're asked to simplify the expression, and we want to write the answer or the complex number in standard form, a plus bi. So when you're given a complex fraction, you're not allowed to keep 0 in the denominator, so you want to multiply by the conjugate. To find the conjugate, you're going to take the original denominator and change the sign of the middle. So we're going to multiply by the conjugate, 3 plus 2i. And when we do that, we have to multiply both the numerator and denominator. So now we're going to create two box problems. We're going to have a box with the top, the numerators, and we're going to create a box for the denominators. So I'm going to do two boxes. One's going to be for the numerator, the other one's going to be for the denominator. If you prefer to FOIL or double distribute, that's fine as well. You will end up with the same answer in the end. So remember, when we box, we just want to multiply corresponding boxes or corresponding pieces. So for this top left box, for the numerator, I'm going to multiply 3 times I to get 3i. I'm going to multiply 3 times 5 to get 15. I'm going to also multiply I times 2i to get 2i squared. Keep in mind that I squared is not allowed to be left in your problem. It must be taken out and replaced with -1. So 1 times -1 times 2 is going to give that box a value of -2. And then this last box, 5 times 2i is 10i. So for my numerator of my answer, I'm just going to combine like terms. I want the constants first, so I want -2 plus 15, which is 13. And then combine your imaginary numbers. 3i plus 10i is 13i. So now we want to work through the denominator. So the denominator was going to be 3 minus 2i times 3 plus 2i. And again, we're just multiplying corresponding parts. Be careful when you multiply -2i times +2i, you get -4i squared. I squared turns into -1. -1 times 4 is going to be 4. -1 times -4 is going to be 4. So then when you go to combine like terms, your imaginary numbers will cancel. You're left with 9 plus 4, which is 13. It should stand out to you that you have 13 plus 13i divided by 13. That needs simplified. And while we're doing that, we want to write our answer in standard form, a plus bi. So 13 divided by 13 gives me 1, plus 13i divided by 13 just leaves me with 1i, or you could just write it as I. So 1 plus I or 1 plus 1i would be the correct answer for that one. All right, question 18, we're going to solve the absolute value equation. When we solve an absolute value equation, we first of all have to get the absolute value bars isolated on one side by themselves. We need to start by subtracting 10. So that gives us this equation here. We then have to move this 2 that's sitting out front. Keep in mind that's a positive 2 sitting there. This is like a -1 that's being multiplied. So we're going to subtract 2 from both sides, and that's going to give us -1 times the absolute value of x plus 3 equals -12. To get rid of that negative that's sitting in front of your absolute value bars, you're going to divide by -1. So now we have the absolute value of x plus 3 equals +12. We finally got our absolute value bars isolated on one side, so we're going to break this apart into two problems. We're going to have x plus 3 equals 12, the original, and then we're going to have x plus 3 equals negative 12, because remember, whatever was in the absolute value bars, the whole thing could be positive 12 or it could be negative 12, because when you take the absolute value of it, it turns positive. So then we're just going to take these two linear equations and solve for x. That gives us x equals 9, x equals negative 15. Final answers. Question number 19, we're going to solve the equation. We want to remember to check our solutions in the original to make sure that we don't have any extraneous answers. So to get the radical by itself, in order to get rid of it, we have to move the 4. That's going to give us this right here. Now that we have the the square root by itself, we can square both sides. Biggest mistake I see here is when you square the left side, you have to square the right side, and the right side turns into either a box problem or a FOIL problem, because it actually represents x minus 4 times x minus 4. So you can either box that or double distribute to get your answer. We'll do that in just a second. So the left side's 11 minus 2x, because the square and the square root cancel. So then for the right side, you're going to take x minus 4 times x minus 4. Again, you could quickly box that in. To get x squared minus 8x plus 16 for the right side. Now you have a quadratic. Anytime you end up with a quadratic, you're going to have to move everything to one side and try to factor. So we're going to move the 11 and we're going to move the 2x to get 0 on the left side. So that now gives me x squared minus 6x plus 5, which does factor. It actually factors into x minus 5 times x minus 1. You could definitely use your asterisks on that, or if you have been doing math long enough that you know what it factors into, that's fine as well. So now that we have this, we want to take both of our factors and set them equal to 0. And then keep in mind, we got 2 answers, so we want to take both of these answers and check them. When we check them, we're just making sure that neither one of them gives us an extraneous solution, or neither one is an extraneous solution. So we're going to go back to the original, and we're going to check each one individually. So I'm going to check the first one first, so I'm going to check 5 first, just because it was the answer we got first. And my biggest suggestion on this is that you don't start moving things from one side to the other, that you just leave it as it's written and you just start simplifying one side, in this case, the left side. So for the left side, the first thing I would do is multiply 2 times 5 to get 10. And then I would take 11 minus 10. 11 minus 10 is 1. So now I have the square root of 1 plus 4 equals 5. Well, the square root of 1 happens to be 1, and 1 plus 4 is 5. 5 does indeed equal 5. So that one checks out. I'm going to go ahead and go back to 5 and circle it. I know it's an answer. So I checked it. I got a true statement. I know that 5 is a solution. Now I'm going to go back and check 1. Again, I'm going all the way back to the original. And again, I'm going to pick that left side and I'm just going to start simplifying. I'm going to simplify this first. 2 times 1 is 2. 11 minus 2 is 9. So the square root of 9 plus 4 equals 1. Well, the square root of 9 happens to be 3. So 3 plus 4 is not going to equal 1. So we take that equal sign and we just put a slash through it. That does not equal. So actually the answer of x equals 1 does not work. It is extraneous. So do not circle it. It is not part of your answer. For question number 20, we were given a function. We were asked to find horizontal, vertical, and oblique asymptotes if there were any. The first thing I would do is find the vertical. Vertical happen anytime that your denominator equals 0. So I'm going to take the x squared plus 6x minus 27, and I'm going to factor it. So take a moment, pause the video, and see if you can factor this quadratic. Hopefully you paused the video to find out your two factors were x minus 3 and x plus 9. That means wherever these two factors equal 0, we will have a vertical asymptote. So we have vertical at x equals positive 3 and x equals negative 9. So we're just setting both of those equal to 0 to find our two equations. For our horizontal asymptotes, remember you're looking at the degrees of both the numerator and the denominator. So since these two degrees are equal to each other, our horizontal is just going to be y equals the fraction of those two coefficients. So numerator is going to be 3, denominator is going to be 1. 3 over 1 is just 3. So our horizontal is just y equals 3. And there are no oblique asymptotes. Question 21. We are going to solve this inequality. We want to write our answer in interval notation. So since this is a quadratic inequality, we first of all want to factor the left side. So we want to figure out the two factors that multiply to give us 24 and add to give us negative 10. So that gives us x minus 4 and x minus 6. Set both of those equal to 0 to get values of positive 4 and positive 6. Remember that for this kind of problem, we're going to check intervals. So the intervals we're going to check are going to be the interval to the left of 4, the interval between 4 and 6, and then the interval from 6 on. So we're just going to have to check numbers that fall within those three categories. So for the first one, I'm going to check the first number. I'm going to check 0 because 0 is to the left of 4. So when I check 0, I'm going back to the original equation and I'm plugging in 0 right here and right here. So 0 squared 0, 10 times 0 is 0. So really this boils down to, is 24 greater than or equal to 0? Well, yes. So that interval is going to be part of our answer. And then I'm going to check the next interval. So I'm going to pick a number that is between 4 and 6. So I would just check 5. So 5's right in the middle between 4 and 6. I don't want to use 4 and 6. So I could use 4.5. I could use 5.5, but 5 would just be the one I would choose. So then I'm going to take 5 squared minus 10 times 5 plus 24. And when I do that, I get -1. So the whole left side here equals -1. Is -1 greater than or equal to 0? Well, no, absolutely not. So that middle region does not work. Then I'm going to check a number on the right side. So any number that's greater than 6, not including 6, will work. So I could check 7. So again, I would just go to my calculator, plug in 7 squared minus 10 times 7 plus 24. And when I do that, I got an answer of 3. And 3 is greater than 0, so this region over here works as well. So now I have to write in interval notation these two regions here on the left and here on the right. So the region on the left is going to be -infinity all the way up until 4. And in this case, since the symbol was greater than or equal to, since that equal to was there, we're going to use a bracket for the 4. So there's the first piece, and then we're going to use what's called the union to unite our two answers. It's just a U. And then we're going to write the right side. So the right side starts at 6, including 6. And continues going on forever to positive infinity. So right here is my final answer. So -infinity to 4 and 6 all the way to positive infinity. Question number 7, we're asked to find all the real and imaginary zeros of this polynomial function. This polynomial function will not factor using factor by grouping. So you can't factor by grouping. This is where we're going to have to use that rational root theorem. We're going to take all the factors of the constant divided by all the factors of the coefficient. In this case, all the factors of 2 plus or minus 1 plus or minus 2 divided by all the factors of 2 plus or minus 1 plus or minus 2. So that's going to give me a list of possible zeros. So 1 divided by 1 is 1. 2 divided by 1 is 2. 1 divided by 2 is 1/2. And 2 divided by 2 is just 1 again. So really, I just have 6 possibilities. So looking at these 6 possibilities, I always tend to start with 1 and -1. So I'm going to start with 1. And I'm going to use synthetic division to see if 1 is a factor. So in my synthetic division, here I just need 4 boxes across. Coefficients go across the top, so 2, 1, -5, and 2. The first number always comes down. So we're looking to get a 0 as the remainder. So if 1 is a 0, then we will get 0 for the remainder. So we're going to multiply to get the middle, add to get the bottom. Multiply to get the middle, add to get the bottom. So conveniently, I got a remainder of 0. That tells us that our new equation is 2x squared plus 3x minus 2. There is no remainder, so I don't have to write anything there. And then I'm going to take this new equation and I'm going to see if I can factor it. So I'm going to use my asterisks. Oops. 2 in the top left, 2 in the top right, 3 in the bottom middle, -4 in the top middle because you're taking 2 times -2. So 2 numbers that multiply to give me -4, but add to give me 3. Oops. 4 and -1. We're going to reduce the 2 and the 4 to be 1/2. So now I have factors x plus 2 and 2x minus 1. Now that I have those two factors, I'm going to set them both equal to 0. So you get x equals -2 and x equals 1/2. Keep in mind, when you write your answers, I have that x equals -2 that we just found, the x equals 1/2 that we just found, but don't forget that we also found a solution earlier when we did this right here. So that whatever number you took out using synthetic division is also a solution, in this case x equals 1. So here you have three answers: -2, 1/2, and +1. All right, question 23, we're going to solve this equation, and keep in mind we must check in the original to make sure they both work. So first thing we're going to do is use, we're going to use the product property to combine these two. So since there is addition in the middle of these two logs, they have the same base, we can combine them to be log base 2 of x minus 3 times x plus 4. Well, then I would go ahead and just multiply all of this together. That's just a box problem. So log base 2, when you box them together, you get x squared plus x minus 12 equals 0. Oops, equals 3. Now that we have this, we want to rewrite this in exponential form. So b, so your base of your exponent 2 to the third power is going to equal what's in parentheses, x squared plus x minus 12. Well, 2 to the third power happens to be 8, so 8 equals x squared plus x minus 12. You're going to subtract 8 from both sides to get a new quadratic. So now we have this quadratic that we want to take and factor. Again, that's just an asterisk problem. So two numbers that multiply to give me -20 and add to give me 1, +5, and -4. Set them both equal to 0 to get x equals -5 and x equals 4. Don't circle them quite yet. We've got to go back to the original equation and check them. Keep in mind when we check them, anytime we plug a number into these parentheses, we cannot have a negative. So we can't find log base 2 of any negative number. So I'm going to go and I'm going to plug in -5. So if I go back to the original, I plug in -5, I would have log base 2 of -5 minus 3 plus log base 2 of -5 plus 4 equals 3. Oops. So as soon as I start to simplify, I have log base 2 of -8, I've got a problem. I can't take log base 2 of -8. So automatically I know that this is not defined. Can't be a solution. So then I'm going to, pardon me, then I'm going to check 4. And I'm going to start simplifying. Log base 2 of 1 plus log base 2 of 8 equals 3. So then I'm going to ask myself if I would happen to rewrite this part right here, it would be 2 to the x power equals 1. Well, 2 to the 0 power equals 1, so this holds a value of 0. Plus, if I do the same thing to the second log, I would have 2 to the x power equals 8. Well, 2 to the third power equals 8. And then 0 plus 3 is 3, so this second answer works. X does equal 4. Question 24, we're going to solve this equation. We're going to round our answer to the nearest 4 decimal places. We do not want to round anything until we're on our last step. So first step, we want to get 5 to the 2x minus 1 isolated. So we want to get rid of this 4 by dividing both sides by 4. So that gives us this right here. Then we're going to rewrite this in log equation or log form. So log base 5 of 2 equals your exponent 2x minus 1. Well, I can't type log base 5 of 2 in my calculator, so I would have to use the change of base, log of 2 divided by log of 5, and that's going to equal 2x minus 1. Well, we still want to get x by itself, so we're going to add 1 to both sides. Now things are getting really complicated. So now to get x by itself, we need to divide by 2. Well, to divide by 2, we would take this whole entire left side and divide it by 2. So I would definitely use my calculator. I'm going to go back up here. In my calculator, I'm going to use one big parenthesis, log 2 divided by log 5, plus 1. You might have to, depending on your calculator, use another set of parentheses around the log 2 divided by log 5, plus 1, then close your big parenthesis, and then divide that answer by 2. You could do it in pieces, take log 2 divided by log 5, hit equals, and then put plus 1, hit equals again, and then divide by 2, and hit equals. You should end up with an answer of approximately 0.7153. Again, remember our instructions told us to round to the nearest 4 decimal places. And last question here is going to be a composition of functions. So we're given f of x and we're given g of x, and then we're being asked to find the composition f of g of x. So we're going to take the function g of x and we're going to plug it into f. So we're taking this entire piece right here and we're going to plug it in right there. So I have the 3 out front, and then instead of writing x, I'm going to write the parentheses 2x minus 7. Close my parentheses because the squared's still on the outside and the plus 5 is still hanging out at the end. Tricky thing is here, this is a box problem. You're going to take 2x minus 7 times 2x minus 7. That's going to give you 4x squared minus 28x plus 49 when you combine like terms. And then the 3 and the 5 that were out front and behind just get brought down. Well, to eliminate my parentheses, I need to go ahead and distribute the 3. So 3 times 4x is 12x squared. 3 times negative 28 is negative 84x. And 3 times 49 is 147. Again, bring down that plus 5 because we haven't done anything with it. So to get our final answer, all we need to do now is combine like terms. So 12x squared minus 84x plus 152 would be our final answer. that is the end of the Math 136 final review. If you have questions or concerns, please feel free to reach out to me and get some extra help. Feel free to watch the video again. Again, pause it at any time. I know I get to talking kind of fast, but you've got this.